Today I'm going to be going over a couple of things with us. We're going to be explaining and going over UDP and TCP and how it works. Now, User Diagram Protocol UDP is a communication protocol that facilitates and exchange messages between computing devices in a network. It is an alternative to Transmission Control Protocol TCP, a network that uses the internet IP. It is sometimes referred to UDP IP. Now, UDP divides messages into packets called a diagram or datagram, which then can be forwarded by the device's network switches, routers, and security gateways to the destination applications or servers where the UDP does not number or resemble the datagrams. It does include port numbers and the header to help difference and user requests. Now, in the next slide, I'm going to be showing you exactly what I mean about this. Um, with the breakdown of the datagrams, it breaks it down to a smaller code to be sent off to the next location or the person receiving it or the recipient receiving whatever said file and reassembles it for them to get it if they're in a location that's not within the company or within the immediate facility. Now, right here, we're going to be going over the UDP header from the source port. That is where it's being sent from to the location that it's going to be sent to the destination port. Now, like I said from the previous one, it does show that there's going to be some datagrams, meaning um, the information being set as 16-bit. Now, the link does differ between, it can't exceed the maximum of 16 bits. That's where sometimes we'll have that lengthy issue of being rejected or vetoed and being sent back. Now, the checksum is where it is received, so the person can view that email. This is for the UDP data on how it's being seen. Now, transmission control, TCP, is a connection-oriented communication protocol that facilitates the exchange of messages between computing devices and a network. It is most commonly a protocol in the networks that use Internet Protocol IP together. These sometimes referred to as TCP/IP. TCP does take messages from the application server and divides them into packets, meaning, like I said earlier, it breaks it down to where it can hopefully then be sent over to the destination of who it's going to. Now, within the network, switches, routers, security gateways to the destination, TCP numbers each packet and reassembles them prior to handling them off to the application server of the recipient. Because it is connected oriented, it ensures that the connection is established and maintained until the exchange between the application server sending and receiving the message is complete. Now, here's a couple example over the next two slides that I'm going to be explaining to you on how this works. When an email is being used for a simple email transfer protocol, SMTP, it is sent from an email server to a TCP layer. On that second diagram, this is where I showed you from the datagram that from the header, it is sent to the server or that source. And that server, it will divide the message up into multiple packets, meaning the length from that diagram. Then the number is then forwarded back to the IP layer of the transport, meaning the destination of the individual that it's going to at the IP layer. Each packet will be transported to the destination email server, while each packet is going to the same place. The route they take can be different may be different, and when it arrives to the IP layer, it hands it back off to the TCP layer, which resembles the packets into a message and then hands it to the email application where it shows in their inbox. That would be the checksum list and back to the UDP datagram. Now here's the application of the FTP, TCP, IP, Ethernet driver. It works both ways from user to user, from one destination to the next. Here you're seeing in the red lines the best effort that it does and showing how it resembles and how it gets there when you break it down. It goes from one layer, reassembles, and goes to the other layer of the destination and reassembles there for that individual to receive whatever the information is that was sent from the original source to the destination. TCP information is transfer protocol. It is one of the main protocols on the Internet Protocol Suite. It is originated in Intel Network Implementation, and which it is complemented the Internet Protocol IP. Therefore, the entire suite is commonly referred to as the TCP IP. It does provide reliable order and error check delivery of a streamed or octet bytes between applications running on a host communication via IP network. Major internet applications such as the World Wide Web, email, remote administration, and file transfer rely on TCP, which is part of the transport layer of the TCP IP suite. The SSL TLS often runs on top of the TCP. Now, later I will be showing you another diagram on the information on how this also breaks down. The TCP connection is oriented, the connection between a client server is established before the data can be sent. The server must be listening or a passive open for a connection request for the client before connecting is established. Three-way handshake. Active open transmission is an error detect that adds reliability but lengthens the latency. Application does not require a reliable data stream. Service may use the user's datagram protocol, UDP, which provides a connection list diagram. Server that prioritizes time over the reliable TCP employs network congestion avoidance. However, there are vulnerabilities to TCP, including denial of service, connection hijacking, TCP veto, and reset attack. I went over this earlier, not in great detail, but denial of service is if a file is too big, can't be sent, it will be sent back to the original source, saying that the recipient cannot receive this. Please change whatever to it. Because it has a max limit of a byte. So you may need to, if it's a program or a video, you may need to zip it before sending it back off, because it then compresses the data from that video, so it isn't lengthy. Now, how is TCP complex? Through TCP, it is a completion protocol. It is a basic orientation, has not changed significantly since the first specification. TCP, dominantly used in the web, IE or HTTP protocol. Now, this is commonly for the second layer of HTTP2, but not regularly used on HTTP3. The Transmission Control Protocol does provide communications and services at an intermediate level between an application program and Internet Protocol. It does provide host-to-host connection at a transport layer of the Internet model. An application does not need to know the particular mechanism for sending the data via link to another host, such as a required IP fragmentation accommodation with the maximum transport mission unit. And now, off the transmission medium, the transport layer TCP does handle the handshaking transmission details, present abstraction between network connection and application, typically through network sockets interface. Here's an example of something like this would be Zoom. Now, Zoom is a video conference or voice conference. I'm sorry. Um, Now, in there, you can talk, video, chat live, but if you need to send a file to it, it does host that possibility where you can send the program or information through a file through Zoom and for that other individual to download that information from. This would be something that can be commonly used to on that application all the time. It does have its limits on exceeding specific standards, which is commonly also noted within the user's agreement for Zoom. Now let's continue. At a lower level, the protocol does stack due to network congestion, traffic load balancing, unpredictable network behavior. IP packets may be lost, duplicated, or delivered out of order. The TCP does detect these problems, requests retransmissions, and lost data, rearranges out of order data, even helps minimize the network congestion to reduce the occurrence of the problems, and the data still remains undelivered to the source. It notifies the failure once the TCP is received. It has resembled the sequence of octet originally transmitted. It does pass them and receive the application. Thus, TCP abstracts the application communication from underlying network details. Now, before we go, regarding this, same thing happens. Originally, when a TCP does detect the problems, the request is retransported to the person that says this is what happens. Now, I won't tell you exactly how it happened, but commonly this is rejected or cannot be sent through because of the sizes more than the allowable information that can be sent. It might be too big. Now, this can also be looked up. Other information can be shared through wiki or any books through dummies. Does help a lot with understanding the information. Now later I might be doing some more videos regarding this, but I hope this helps you understand some information on UDP and TCP. Now, if you have any other questions, leave a comment down below, and I'll be more than happy to help you. Thank you for watching, and I hope you'll have a great day.